Hey guys, this is Fozon, and in today's lesson we're going to be discussing algorithms that we can use with array lists. Our lesson objectives, we're going to construct the standard algorithms with array lists. So the goal of these standard algorithms is not to get a broad summary of what you can do with array lists. It's supposed to be used as a stepping stone to make it a little bit more easier to make more advanced algorithms. So if you understand how these standard algorithms work, then you pretty much know how to make other algorithms, maybe in the APCSA FRQs. So the goal is understanding how these traversals or removing or adding elements to the array list work and what we should be accounting for in our computational thinking. So the first algorithm we're going to develop is a delete object algorithm. Then we're going to develop a min or max value algorithm. Then, just like the arrays video, we're going to find the sum and average. Determine if the list has a specific characteristic. We could do this two ways. One is if they all have the same characteristic, checking if they all have the same characteristic. That will most likely return a Boolean value. And then the other algorithm we could develop is determining how many values within an array list actually have a certain property. And then finally, we're going to do finding duplicates and then removing those duplicates. So let's go on to the compiler and actually make these algorithms from scratch. So we're in the compiler, and let's work through every single algorithm one by one. Before I actually talk about the algorithms, let's first look at what I have in the compiler already. So I have a printAL method, printArrayList method, and it takes in an array list argument, and then through for loop it prints out every single value within the argument's array list, within the array list arguments. And then it simply also prints out the size as well in the final statement of the method. We invoke this method from the main method, and we have an array list created. Don't worry too much of how I created this array list. The best way I can explain it is that this is like a initializer list for an array list. You don't need to know this. However, it makes my job in developing these algorithms and testing them a little bit more easier. But rather than having a .add method every time I want to add a value, I have these list of values right from the instantiation. So again, don't worry about how I created this array list, but just know that this makes my life a little bit more easier. So the first thing I want to do is I want to remove an object from an array list. So how do we do that? Well, we first create our helper method, public static void, and then let's do remove object. Let's take in an integer array. So the precondition will have to be an integer array, or rather, to be more specific, an integer array list. Integer array list. Let me put that as a precondition. And let's make sure that the size is greater than 0. Now within the arguments, it's of course going to take in an array list integer, an integer array list. So let's put that as the arguments. And let's name it Ari. We also need the value that we want to be removing. Since this is an integer array list, we're going to be removing an integer value. Now that we've created our method declaration, you're probably wondering why we have a void value here. Well, when we're passing an array list within through an arguments, it doesn't actually create a copy of the array list. What it does is that it sends the memory location. We see this not with just the array list, but with all objects in general. It doesn't make a copy of the object, since it doesn't use the new keyword. It simply passes the object location. So if I edit the array list within this method that I got through the arguments, it's going to make the respective change here. So I don't really need to return an array list and then restore it within my main method. If I edit it within, if I first of all send it through the arguments and then I edit it, then it will make that respective change here because they're pointing to the same memory location. So I don't have to use a void statement unless I need to. For integer I is equal to 0, I is less than, how do we get the number of elements within our array list? Well, we do array.size, and that's the size method. The size method allows us to get the number of elements. And then we're going to increment our loop control value. Again, the reason why that we start at I equals 0 is because when we're accessing a position of the integer array list, then we need to start at 0 because position 0 is the first element, and it goes on to the number of elements minus 1. It's just like an array in that characteristic. Now we need to see whether or not if it has a value. And if it has a value, we want to remove it. So we do array.get size, array.get, not size, and then we get the value that it's currently at, and then we see whether or not it's is equal to the target value that we have here. So let me relabel this as target. So if the value that we're at is equal to the target value, then I want to remove that value. We remove the value through the ArrayList remove method, array.remove. Now here's a little bit of computational thinking. Now that I've removed the value, what happens to the array list? That doesn't happen with an array. Well, within the array, it maintains the same size. So we don't have to worry about the loop control variable skipping any value. However, with an array list, what happens is that any value that was already greater than I, or that had a position greater than I, will now be shifted to the left, or will be decremented. Their position will be decremented. So if we increment it here, what will happen? We will be skipping a value within our array list, and we don't want to do that. So what do? We decrement it so that these two things cancel out. Because the I position after we remove it is actually a different value altogether. Let's see if this works. So let's throw in my integers. That's the name of our array list. Let's access the method. So remove object, and then we'll put in our array list argument. So my integers is the name of our array list. And then what do we want to remove? Well, I want to remove 2. And we have two 2's here. So hopefully it goes from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I want to print my method. I want to print it out after it is done, after it removes the two values within my array list. And as you can see, it removes the two values. I can invoke this method a multitude of times to remove any value that I want. So let's say remove object, and let me remove 4, as well as 10. Let's see if this works. So hopefully it should remove all the 2's, so all the 2's, all the 4's, and all the 10's. So it should have a size of 7. So we have our original array list, and it removes our 2 values. See, we don't have no longer 2's here. It removes our 4 values. See, it goes from 3 to 5. And we don't have our 10 value. 10 was our last value within our array list, and it removes it from the array list. The next method we're going to do is the method that finds a minimum value and then removes it. So let me create a minimum method. Public static void find minimum. Let's take in an integer array list and name it Ari, just like we did with the previous method. And let me make sure that it's an array list and not an array. Now we can make this method a bunch of ways. We can have it just simply remove the the minimum value, or we can actually return the minimum value altogether. So let's do that. So for integer I is equal to 0, I is less than Ari dot size, and make sure it's less than, not less than or equal to, and then we increment the loop control variable. This will allow us to traverse through the array list to find the minimum value. Now the thing is that we want to remove the value as well as find the minimum value. So what I'm going to do is I'm going to create two integers outside of the for loop, because we want to access these values when we want to remove it, or if we want to compare it to the other values. So let me make one value that gets the position, and let me set it equal to -1. Then let me let me make a integer, and this is going to store the minimum value at a certain iteration. Let's set it equal to the largest integer that Java can handle. We start big, and then we work our way down to find the minimum value. Now let's make a Boolean expression through an if statement that finds a value, that finds the smallest value within the array list. So we're at a certain iteration, and we want to see if the value at that current iteration is less than the minimum value. If it is, then let's update the position, and then let's update the minimum value. So let's do that. If, then we get the element that we're at. That's how we get the element that we're at currently. And if that is less than the min value, then I want to update my min value and my min position. Let me rename this to min position so it makes a little bit more sense. So the min position is going to be the value of our minimum position at a certain iteration. We'll set that equal to I if this gets invoked. We could also, or we will also, update the min value, and that's going to be the value that we're currently at, array.getsI. This loop will iterate until it is done with the array list, and until it's done seeing every element within the array list, and it makes the determination of which is the min value, and then where that min value is stored within our array list. Let's remove it from the array list. So we access it. It's not array, it's Ari. Dot remove. And how do we remove a value? Well, we put it within the arguments and then the value that we're removing, min position. That is the position of where we're removing. Now we can leave it like this, and let's see if it actually works. So let me first remove these values, or remove these method calls, and let me call to a different method. Let me call to find minimum, and then I put in the myIntegers argument. Hopefully it should remove 1 because 1 is the minimum value. And as you can see, it removes 1 from our minimum value. What we can also do is actually return the minimum value to the main method. How do we do that? Well, if you recall, the remove method actually has a return type of, well, object, depending on the array list. So if it's an integer array list, then it's going to return an integer, the integer that you're removing. So let's actually return the value that we're removing. So integer a is going to be equal to that, and then we're going to return integer a. Now we need to update our method declaration so that it knows that we're returning an integer. Finally, when we are accessing the find minimum method. Since it's returning an integer, let's update or put it around a print statement. And the print statement, what it will do is print out the minimum value. Let me make sure the print statement is written correctly. And as you can see, it's a little bit congested there. Let me remove this so that it doesn't seem too congested. So if you look at the array list within my array list declaration, you can clearly see that 1 is the minimum value, and it removes it from our array list, but it also finds it and returns it. So that is very important to note, that the remove method, what it does is that it not only removes it, but the return type of the remove method of the array class is the returns the value that you're removing. So you could actually store that and then send it to wherever you want if that is necessary for your algorithm. Again, this comes with practice and knowing when it is appropriate to use this return type. Let's move on to the next algorithm. I'm sure that you can update the values. You can update this algorithm for finding the maximum. Realistically, the only thing you have to do is change this from max to minimum, and then change this from a less than sign to a greater than sign. You can also change the variable names, but again, Java treats the variable names as more as an object location than it does as, finding minimum position or finding minimum value. The next algorithm is going to be finding the sum and average. So let's do that. Public static void. Actually, instead of making it a void, let's make it an integer so that it returns the sum rather than printing the sum. And we're going to name it find sum. It's going to take in an integer array list. Let's name it Ari, and the curly brackets. So we really don't need a regular for loop for this. We can just use the for each loop and then keep adding to the total that we initially set. So the for each loop can be utilized with an array list, and we could do so like this: an integer val, and it's going to take in every iteration or every position that it's at. The integer value is going to be from the array list Ari. Now, to make sure that the total can be returned once it's done and can be shared through every iteration of the for loop, we declared outside of the for loop to make sure that it doesn't go out of scope through every iteration. And we set it equal to 0 because the sum will start at 0. We could do total is equal to total plus val. This will continuously keep adding every element within the total. You could also rewrite this as total plus equal val, and that will yield the same thing. But just for the purpose right now, I'm just going to keep it as total because it makes a little bit more clear to show you how the algorithm works. And then we're going to return total. There you go. So let's see if it prints out the total or returns the total. So let's remove this and put it as total. Let me remove this print al method for now. And rather than finding the minimum, we're going to find the sum. Let me make this array list a little bit more simpler. And let's do 1, 2, 3, 4. This will hopefully have a sum of 10. 1 plus 2 is 3, 3 plus 3 is 6, and 6 plus 4 is 10. And it prints out 10 because it continuously keeps adding the elements into the total that we have here, and then eventually returns the total. Now let's find the average. Public static integer. Let's do find average. And we'll take in an array list. Let's do integer. And let's name it Ari. Now what we can do with this is that we don't have to make a, since the average requires since the average requires us to find the sum first, we don't need to make the sum algorithm within our average method. We could just call the find sum method and get the total. So let's do that. Integer total is equal to, since this has a return type of integer, we'll do find sum, and then we'll put in our array list that we want to find the sum for. Now what we want to do is we need to find the average. So since the average can be a double, let's make sure that we have double average, and let's set that equal to total divided by Ari. And how do we get the number of elements within our array? Well, we access the size method. To ensure that we don't have any issues with the casting or dividing an integer by an integer to only get an integer, we will cast total and make sure that it gets converted from an integer to a double. This will allow us through casting. We're able to convert the total value from an integer to a double. Then let's return the average. I also made the mistake again of giving an integer return type within my method declaration. Let's change that from an integer to a double. So now it's returning a double, and it returns a double. Let's access this method through the main method. Let's do find avg, and then throw in my integers. End with the semicolon, and let's run it. And as you can see, it returns 2.5 because 10 divided by the number of elements that we have, 4, is 2.5. Now let's do an algorithm that finds a certain characteristic or sees whether or not a certain characteristic is consistent along all the elements within our array list. So let's make an algorithm that checks whether or not if all the values within our array list are even numbers. Public static void. Actually, since we're checking to see whether or not they're all even numbers, let's return a Boolean expression that tells us whether or not they're all even numbers or all odd numbers, or not all even numbers or not all even numbers. Then we're gonna name it find even, or see. Actually, let's name it find even though it's not completely accurate. We're just using it just for the purpose of the name. And let's name it Ari again. So let's traverse through the array list. So for integer val, and since we're not returning a position, we can just use the for each loop. Now within the for each loop, we want to see whether or not if it is false. If it's an odd number, because if it's an odd number, that means the entire array list should be returning false because we found an odd number within our. Technically, we want to see whether or not they're all even numbers, and if they're not all even numbers, well, then we should be returning false. So to check whether or not if it's a false number, we do an if statement, and then within that if statement, we see whether or not. Let me see. Modulus 2, and if something's modulus 2 and has a remainder of 1, that's an odd number. And if it finds an odd number, all I want my method to do is return false. Now if this for loop goes through the entire array list, because if this for each loop traverses through every single element, that means that it did not invoke this method, because if this method is invoked, that means the for each loop will never end and we'll never see anything that's after this curly bracket that I'm circling right now. So if it actually reaches this point, then this method never gets invoked, meaning that there is no odd number. So it would return true. Let's see if this works. So let me erase this, and let me do this as well. And rather than finding sum, let's do find even. So with the values that we have currently, it should hopefully return false. And as you can see, it returns false because literally the first element that it sees when it's traversing, it plugs it into this if statement. 1 modulus 2 is in fact 1. 1 is equal to 1, so it returns false, and it doesn't even look at the true statement. Now let's just remove the odd numbers and see whether or not it works with just even numbers. And as you can see, with an array list of even numbers, I have just 2 numbers, but the point still stands. I could even put a couple extra even numbers just to make sure. And the reason why it still works is because these are all even numbers. So if it traverses through every single element, it plugs in 2. 2 modulus 2 is 0, 4 modulus 2 is 0, 6 modulus 2 is 0, and 8 modulus 2 is 0. So this if statement never gets invoked. Sorry, the values within, or the statements within the if statement, are never really executed because this is always false. It's never equal to 1 with this specific array list. So it goes through the entire for loop and it doesn't invoke this method. So it expects another return statement, and we put in return true because it went through that entire for loop without finding an odd number. Now we can change this so that rather than returning a Boolean expression, it returns the number of even numbers within our integer array. So let's change that from Boolean to integer. Let's keep track through a count, an integer count, and let's set that equal to 0. That increments whenever it finds an even number. Now within our if statement, rather than finding whether or not something is an odd number, we want to see whether or not something is an even number. And if it finds an even number, it's going to increment count by 1. You could do count is equal to count plus 1 as well, but count plus plus looks a lot more better. And then after the for loop is executed, we're just simply going to return count. Let's see if this works. So with this array list, it should technically print out 4 because every single element within our array list in this array list is in fact an even number. So it should print out 4. And as you can see, it prints out 4. But let's see if I start sticking in odd numbers. So let me put a couple odd numbers there. Let me put an odd number there. And let me put an odd number there. Will it still be 4? Well, I mean, just to make sure that I didn't put in an even number by accident, we have 1, 2, 3, and 4. So we should have 4 even numbers still. Let's do that. And as you can see, the number still stands even when we add numbers, because this is simply counting, or this algorithm simply finds if how many elements are even numbers. And that's how you check to see how many elements are there in an array list that have a certain characteristic. In this case, it's being an even number. Now for my final method, I'm going to remove duplicates within an array list. So if you have an array list with a bunch of duplicates in it, let's see if we can remove the duplicates but still have the original value. So let's do that. Public static void. And we're doing void because we're doing all the removing within this method. And as I said before, if you pass it through an argument, it passes the object location. It doesn't make a copy. So if you edit the array list inside the method in here, then you've extended the scope of the array list from the main method to the method that you currently sent it to within the arguments. So let me do remove duplicates. And then let's do integer array list. So what I'm going to do first is make a for loop that iterates through every single value, and that's the value that we want to see if there's duplicates of. So let's do for integer I is equal to 0, I is less than array.size. Again, size has the number of elements. We don't use length with an array list. And then we increment it. Now we have another for loop inside this for loop. And what this does is that it finds the values that we are comparing to the original value that we want to find duplicates for. So if we are starting off at 2, the for loop is going to, what the outer for loop is going to do is that it's going to find 2, and then it's going to compare 2 to, and then the inner for loop is going to compare 2 to 1, 4, 3, 6, 5, 8, 7. And then when we finish that iteration, what the outer for loop is going to do is set I equal to this position that we're at, 1. And then the inner for loop is going to compare 1 to 2, 4, 3, 6, 5, 8, 7, seeing whether or not it should make any important adjustments. So let's make the inner for loop. To ensure that the value that we're comparing to is not the same value at the same position, we put another if statement. We put an if statement within the for loops, and that will only execute as long as I is not equal to j. Because if I is in fact equal to j, then it's comparing itself to the same position at the same number, and we don't want to do that. What we want to do is we want to compare the numbers, different numbers at different positions, to in fact remove the duplicates from other positions. Now finally, we have another execution that we need to do, another if statement we have to do, and this if statement actually does the comparison itself. So it sees whether or not if the element that we're currently at, or the element that we want to find duplicates for, and then the value that we are currently at within the inner for loop. So let's start off with 2, and it's comparing it with 1. It skips off I is equal to j. It skips off comparing it with itself because that if statement prevents us from that comparison. So it's comparing 2 to 1, then it's going to compare 2 to 4, then it's going to compare 2 to 3, then 2 to 6 through this inner for loop. So we see whether or not the element that we are comparing, that we want to find duplicates for, is equal to the value that we're currently at through the inner for loop. And we use j for that index rather than I. So we use I for the outer for loop, and we use j for the inner for loop. And if this gets invoked, meaning that the value we found a duplicate, then what we're going to do is we're going to remove the value that we're at that current location. So it removes the j index. And if you recall from our previous algorithm, what happens when we remove a value from the array list? All the values after j will ultimately get shifted to the left by 1 value, or gets decremented. So to avoid skipping any values within our array list, or skipping any elements, we decrement j after we remove something. And this cancels out with this, because j, after we remove this value, is a different value altogether. Now just to remind you, we don't have a return statement because we have a void method declaration or void return type. And if we edit the array list within our method because we got it through the argument, then it will make the respective change and we don't have to return it. So let's see if this works. So let me do remove duplicates and do my integers. And then after it removes the duplicates, I want it to print out our array list. Now the first thing I want to do to actually test out this method, I want to remove these values and actually put an array list that has duplicate values. So 1, let's do 2, 2, let's do 5, 5, 5, 5, let me do 6, 7, 8, 9. Hopefully it will keep with 1 copy of 2 and 1 copy of 5, and keeping all the elements in that same order. So let's do that. And as you can see, it keeps one copy of 2 and one copy of 5 and removing the duplicates that we have within the array list because of the algorithm that we develop. And it makes that respective change without us returning anything because the changes are done with the method that we extended the scope of the myIntegers array list to. Well, that wraps up my videos on the standard algorithms of the array list. You could also do a bunch of other algorithms that you can do, and you can look on that on the College Board website to practice any algorithms or any array list questions that you might be asked. Now, you will also be asked on things like strings or maybe even doubles, and just keep that in mind. You have to adjust these algorithms or maybe add on to these algorithms when it's appropriate and when it is necessary. So hopefully you don't see this video as a summary of these algorithms. More or less, it's a stepping stone for you to do greater things with ArrayList. Thank you for watching my video.